25, which will cover congruence and similarity, which are two concepts that kind of apply to everything in geometry. So this picture demonstrates congruence. What you see here is you have this little arrow A, and it's congruent to all of those blue arrows. Notice the ones that are shaded in white, like for example, this one is a little bit smaller. This one right here is a little bit too long. This one is too long and too skinny. This one is just not even close to the right size. But notice these ones, even though they're facing a different direction, the blue ones are the exact same shape. And it's the exact same size. So congruence is when you have the exact same shape and size. And the way you have congruent figures is if rigid motions will map one onto the other. So I don't have to stretch or shrink this. I literally just rotate it and scoot it to the right, and there we are. With this, I rotate it to point up, scoot it to the right and down. A different concept is the idea of similarity. What similarity is when you have figures that are the same shape, but they are a different size. So for example, right here, this rectangle is the same as this rectangle. It's just this is a bigger version of the same rectangle. So what you'll find is, so this one is 1, 2, 3, 4, 5 by 2. So then this one will be a similar ratio. So what it will be, so 2, if you multiply that by 2.5, you'll get to this length. So whatever this is, multiply it by 2.5, you'll get to the same length. So like the comparison in their two sides are the same. It's just that this is a bigger version of it. So that's the difference between similarity and congruence. So let's look at this one. So I want you to try answer this as best you can. Do you think they are congruent? And explain your answer. So press pause, try this, and then press play. Okay, so hopefully you said yes. They are congruent. One thing you could do to check is you could look at this. This is 1, 2, 3 by 1, 2, 3, 4. And then this one right here is 1, 2, 3 by 1, 2, 3, 4. So you can see that this side is moved to right here, and this side is moved to right here, but they're still the same thing. So this one is rotated and it's moved over. So could a single translation, reflection, and rotation map one of the triangles onto the other? Do you think you could get this to here with one single motion? And then if not, then could you get a rotation and then a translation? Could a rotation followed by a translation move this to that? So think about 2 and 3. Don't just go quick. Just think it through. Think if they're possible. And then, so press pause, think them through, and then press play. Okay, so there's no way to move this to this in one single motion. Any rotation, there's nothing that'll work. But number 3, a rotation followed by a translation. If you rotate this around this corner right here, so that this side that's 3, the length of 3 is right here, 1, 2, 3, right? You see that? So this side that's 3 units long is now right here at 3 units long. And then this side that's 4 units long is right here at 4 units long. So our triangle is going to be right here. And then we're going to move it up 1, 2 over 1, 2, 3, and it would be right there. So rotation followed by a translation could map this onto that, and that is ultimately how you can prove that two shapes are congruent, is by doing a set of rigid transformations, meaning transformations that don't change the size or the shape, just movements to move one to the other. Okay, so now what we're going to do, we're going to try to actually compose these ourselves. So use this figure for 4 through 5. Do you think that A, B, C, and B, E, F, G are congruent? Are these two congruent? What do you think, yes or no? So press pause and then try it yourself. So what did you think? Did you say you think they're congruent? If you said yes, you are correct, because they do definitely look congruent, and then we're about to prove it. So we have B, A, C, B, E, F, G. Okay, so since we do think they are congruent, we need to answer this. Which set of rigid motions can map B, E, F, G onto A, B, C, D? So which one can map this figure onto that figure? So what I'm going to do is I'm going to go through what they have, I'm going to go through the options we have there and see if they seem reasonable. So this says a reflection across EG. So reflect across EG followed by a clockwise rotation of 90 degrees around point F. So let's think, if we reflect across EG, so EG is this right here. So if you flip this over itself, you're not going to change anything about the shape, but what would happen is F would be right here and then B would be over there. And then once we do that, it then says, after we do that, we then rotate clockwise 90 degrees around point F. So if you flip them, F is now right there, and then we rotate clockwise 90 degrees around F. So remember, F is right here. If you then take this and rotate it like that, right? So now it's going to be like this. Does that map this onto that? No, it doesn't. It doesn't. So that first option isn't going to work. Look at the second option. A counterclockwise rotation of 180 degrees around point B, followed by a translation by the directed line segment. Hold on. Let me change the view. There we go. Okay, now we should be able to see the whole answer. Excuse me. All right, here we go. So a counterclockwise rotation of 180 degrees around point B, followed by a translation by the directed line segment FB. So let's do a 180 degree flip around B. So that would take this and would put it right here. You see that? It would take it, rotate it to right there. And then now that it's right there, we then need to flip it. We need to move it by the directed segment FB. So F would then be over here. So this would be the new F. And we're going to move it, whatever the length of FB is, we're going to move it that amount. So FB is this distance, so scoot the whole thing over to there. You see that? You take it, you rotate it so that it's right here. And then now that would put, if you rotate it around it there, F is right there, B is right there. Then you scoot it by FB, it's right back where it started. That wouldn't accomplish a single thing. So look at our third option here. Clockwise rotation of 90 degrees, so clockwise, 90 degrees around point B. So this time we're going to go 90 degrees around point B. So a clockwise rotation of 90 degrees around point B would put us down here, actually. This last, when we did it the first time. So, but we'd be down here with B right there. E would be right here. F is down here. And then G is right there on top of point C. Do you see that? So, like, I know we've got a lot going on now. So this rotates down there. B is still the upper point. E is now that little corner. F rotates down to there. And then G, this corner G, rotates to there. Okay, so, and then the next thing they want us to do is to do a translation by the directed segment CB. So CB, CB is right here. And so they want us to then, hold on, let me make sure I'm reading this correct. Okay, so 90 degrees around point B. Yeah, I am doing this correct. So, you know what? I'm gonna change something about this. I'm sorry to do this while we're in the middle of it, but I want one of these answers needs to work, and there's a typo right there. So I'm gonna fix this. This should be saying we're gonna say EB. That'll work. Okay. So I'm sorry about that. Let's try this now. So now it's gonna say EB. Yeah. So now we do followed by a translation by the directed line segment EB. So this will actually get us where we want to go. So we're going to then take this thing we have down here and move it by the distance of EB, which would be this distance right here. So move this to right there. This little line that you're seeing right here would be right here. Move this whole thing by EB, which would move it right there. See, if this whole shape slides up to there, then it maps right on top of the other one. So that's the kind of thing that we do with congruence, where we see that, yeah, if you take this, rotate it, and then scoot it diagonally, it's right on top of the other one. We see that they're exactly the same thing. That would demonstrate congruence. All right, 6 through 8. So for this, I think it will help definitely to draw what we're dealing with. So for 6 through 8, an arrow is placed with its base at the origin and its tip at the point 0, 2. For each arrow listed below, find the rigid motion or composition that shows the two arrows are congruent. So let's make a base at 3, 3. So we start off with an arrow with the base at the origin and the tip at 0, 2. So okay, so the base is at 0, 2, and the tip, sorry, the base is at 0, 0, the tip is at 0, 2. So the tip is right here, the base is at 0, 0, so basically we have an arrow that starts at the origin and then the base is at 0, 2. And now what it's saying is that we have a new arrow with the base at 3, 3. So 1, 2, 3, comma 1, 2, 3. So here's the new base, and the new tip is at 3, 5. So the new tip is right here. So how do we move that over to that? So we know that they're both the same figure. How do you move that one over to there? So I'm going to just look at the tip. The tip is right here at 0, 2. This new tip is over here at 3, 5. Okay, so I want you to do this first. So press pause. I want you to try to figure out what rigid motion can get this to move to there. Okay, you go ahead and try it. Okay, now that you've done it, hopefully you figured out that the set of motions that can do that, if I just move it to the right by 3 and then up by 3, it should accomplish what I want it to do. So, and this will be the easiest out of all of them. So if we just move it to the right, 1, 2, 3, and then up by 3. So just, picture moving this over 3, up 3. Look at the difference. 0 to 3, you need to go up by 3. 2 to 5, you need to go up by 3. So our answer, when I scoot this out, is going to be right here, T3, 3. All right. Now we're going to have a base. So I'm going to keep my original here for all of these. Now we're going to have a base at negative 2, 2. So negative 2, 1, 2. So here's where our base is going to be. And we're going to have a tip at negative 2, 0. So that will be right here. So now it's going to look like this. Okay, so the base is at negative 2, 2, and the tip is at negative 2, 0. You see that? Base is at negative 2, 2. The tip is at negative 2, 0. So now what happened to it? So for this, let's actually look at all of our options because there's a lot of answers that could do this. So I'll look at what our options are. So we already tried 3, 3. That we know would just move it to the right 3 and up 3. That's not going to do it. What about if we do this? We reflect over the line y equals 1. Let's think about what that would do. The line y equals 1, remember this is at y equals 2. So y equals 1 would be right here. That would be a line that's going like that. What would happen if you reflected over that line? You would flip it, wouldn't you? Do you see that? If y equals 1 is right there, you draw a line across y equals 1 and you rotate over, you reflect over it. You wouldn't move up or down at all because the line is right in the middle of your arrow, so it would cause it to completely flip upside down. Isn't that what we're trying to do anyways? Yeah. So to reflect over y equals 1 would get you there, would get you part of the way there, and then the next thing is to translate negative 2 comma 0, or that means, remember, negative, it's x comma y. So that's to the left too. So what this would have us do is first flip it upside down and then move it to the left too. That would actually do it. So the first option we test is perfect. So that would be our answer there. Okay. Now, number 8. I'll help you draw it, and then I'm going to tell you to pause. I want you to try this one. For this one, so let me get rid of this. Okay, so for number 8, the base is at 4, 0. So 1, 2, 3, 4. So right here, there's our base. And the tip is at 6, 0. So 1, 2, 3, 4, 5, 6. So here's our tip. So look at what we are. We're up here, and we need to somehow face that way and move over there. So let's look at our options. We've already done this first one. We know that what that's going to do, it's going to flip it upside down, move it to the left. We don't want that. We did this one. This just moves it to the right and up 3. So let's try this. This is a rotation around the origin of negative 90. Let's think about what that'll do. Remember, negative is the way the clock goes. So here's the origin right here in the center, and we rotate around that negative 90, which would put us right here. You see what it would do? It would take it and it would make it point that way. That's what we want, isn't it? And then the next thing that one has, after that rotation, we then move 4, 0. We move to the right by 4 places. So if we're right there, already facing that way, and you move to the right, 1, 2, 3, 4. Boom, there we go. So you see how with these, if you just do one step at a time, you can see how it'll work. So there we go for our answer. All right, now I want you to try to do these last 4 questions yourself. Try to do number 9, 10, 11, and 12. So press pause, go through these, and then you can press play. Okay, here we go. So number 9, is F congruent to G? Does that look congruent? I think it does. Which composition can map F to G? So let's see, with this, rotate around the point 10, 90 degrees. The point 10, a 90-degree rotation, puts us over here, because no, we would go counterclockwise, so it would be somewhere over here. There's no way. And then rotate across x equals 0, that's the y-axis, so we flip over that. No, we're going to ignore this. So first, rotate around the origin negative 90 degrees. So that would take this, remember we'd be going clockwise. So that'll take this and it'll move it over there. So now this corner stays there. What would happen would be this corner is down here. So it's 2 to here. And then this side is now moved to right here. And then it goes up like that. So it would be right here. That looks pretty promising so far. And then we move to the right 2 and up 1. So it's right here. And then we're going to move to the right 1, 2, and up 1. Okay, so this is almost there. Let me make sure there's no mistakes again, because that seems really close. So we rotate clockwise. Oh, I made a mistake. I think this is gonna work just fine. I'm picturing this as if I rotate counterclockwise. You would rotate clockwise. So what would happen, so when I was describing where this would be, I made a mistake. Here, in fact, let me clear this up. I'll go ahead and zoom out and draw this one. This is a good question. This kind of lets us, this is a good test of all the skills at once. So 1, 2. So you see what we have here is we have this thing is 2 and it goes down 1, 2, 3, 4. So what's going to happen here is we're first going to rotate. We're going to rotate. So we're doing a rotation around the origin of negative 90 degrees, which my mistake when I was trying to just kind of do it in my head without drawing it is I rotated it over to there. That's wrong because this way is counterclockwise. That would have been positive. A negative rotation goes like the clock, like that. So we'll rotate this over to there. So what would happen is this side that's too long ends up here, right there. Because it rotates, it's right here, it's going to rotate like that. And then this side right here that's 4 units long will be right here. So it'll go like that. Do you see that, how it's facing like that and it rotates to face like that? So basically, if you want to just focus on one side, this side that's 4 units long will be right there 4 units long. Or this side that was 2 units long goes up there to be 2 units long. So that's where it would be. And what we're trying to do is we're trying to get it to map onto G, which is over here. We have 1, 2, 3, 4, 5, 6. So G starts over here at 2, 1, and it goes over 1, 2, 3, 4. So now we've done that, and then we need to move to the right 4. No, I'm sorry. We move to the right 2 and up 1. So we move to the right 1, 2, and up 1. You know what? This still isn't quite going to do it because look what it'll do. It'll move to the right 2 and up 1. So it'll end up being like right here. So that's actually close, but that's not quite it. So let's try the last one. C wants us to move. So we're starting off right here again. So for C, we're going to go translate up 1 over 1. So up 1 over 1. So we'd be right here. So you see, we take the whole thing, move it up 1 over 1. And then it wants us to rotate around the origin 90 degrees, which would move us. Here's the origin. A 90-degree rotation would move us over. It would make it rotate like that. That's not going to do it either. All right, so it looks like we have an issue where none of the answers are correct, which is a problem because there's definitely supposed to be a right answer. Let me see if there's a mistake on this. Here's what I'll do to keep from wasting your guys' time. So there's a mistake right here on number 10. One of these is off on the current version that I'm doing. So let me finish this lesson and then I'll see what's going on with this. So right here is G congruent to H. G is not congruent to H. Look how much longer it is. So when I ask you to answer this, you're just for sure going to do this. This is just not going to work. Right here, no, they are not congruent, so there's no composition that can map G to H. Okay, but now we're here. Either there's a typo on one of these, or I'm doing something wrong when I'm demonstrating it. Let me double check one thing. Okay, so B, when I made this, I thought B would work. So okay. Okay, so what I'm gonna do, I'm gonna mess with this because I don't want you to sit here and watch a video of me figuring out where I went wrong. So everything on here is good, everything but number 10. I'll attach a second video going over number 10 in a second. So go through all of this, make sure you got it down, and then I will post a second video at the bottom of this lesson where I'll go over number 10. So that'll be at the end of the lesson. Number 10 will be all figured out.